We're here at the example table, and in this video we're going to talk about factoring quadratic polynomials. We're going to look at 3 examples, and they're all examples that are simple enough that we can more or less look at them and know how to factor them. However, it's useful to talk about the specifics of how we can do this. So our first example, let's look at x squared plus 7x plus 10. Now, we want to factor this. So let's write the basic form that we know it's going to take. It's going to take the form of x plus a times x plus b. It factors into 2 linear terms, if it factors at all. And since it's just x squared, the coefficient here is 1, we can put a simple x for these 2 terms. The question is, what are a and b? Well, we know that if we expand this, we get x squared, I don't need a parenthesis there, we get x squared plus ax plus bx, which we can write as a plus b times x plus ab. And we want this to equal x squared plus 7x plus 10. The x squareds will be fine, and from this we know that a plus b must be 7, and we know that a times b must be 10. So if we look at a times b equals 10, we only have a few possibilities, plus or minus 1 and 10, plus or minus 2 and 5. We can take care of the signs by looking at this. We know that a and b must have the same sign because their product is positive, so they must be either both negative or both positive. We know that they add up to a positive number, which means that a and b are both positive. So the factors of 10 that add up to 7 are 2 and 5. So we get x plus 2 times x plus 5. Let's look at another similar example. Let's look this time at x squared plus 3x minus 10. We can set it up in the same way. We get x plus a times x plus b. And just as before, we want a plus b to equal 3, and a times b now to equal negative 10. Before, we had a times b equals positive 10, so we knew that a and b had the same signs. Here, a times b equals negative 10, which means that one must be positive and one must be negative. We also know that their sum is positive. So the positive number, whichever one that is, must be larger than the negative number. We don't have too many possibilities to check. Again, 1 and 10 and 2 and 5 are our possibilities. 1 and 10, there's no way to get 3 from 1 and 10. If we set these equal to 2 and 5, we can do it, except we need 5 to be the larger one and negative 2 to be the smaller one. So we get x plus 5 times x minus 2. Remember, we knew to make the 2 the one with the minus sign because the sum here had to be plus 5 minus 2 to give us 3. Let's look at one more example. This time, let's look at x squared minus 3x minus 10. Same setup. We'll set it equal to x plus a times x plus b. And we know that a plus b is negative 3, and a times b is negative 10. Just as before, a and b must have opposite signs, except now their sum is negative 3. So this means that whatever the larger of the 2 numbers is, we'll get the subtraction sign. So this time we have x minus 5 and x plus 2.